Midnight, a small room, no luxury, no university lab, just silence, paper, and a mind that refused to rest. While the world slept, one man claimed that numbers came alive before his eyes, not in a classroom, not on a blackboard, but in his dreams. What if the answers to the hardest math problems did not come from long calculations, but from sleep itself? What if the human brain could keep solving mysteries even when the body shuts down? This is not fiction. This is the real story of Srinivasa Ramanujan, one of the greatest mathematical minds in history, a man who said that many of his groundbreaking formulas were revealed to him while he was asleep. He would wake up and write them down immediately, as if they had been delivered fully formed. No rough work, no visible steps, just final answers that later stunned the world. Some of those formulas were so advanced that mathematicians could only prove them decades after his death. How could a man with almost no formal training produce results that even experts in Europe struggled to understand? Was this divine inspiration, as he deeply believed? Was it the raw power of subconscious genius working beyond conscious limits? Or is there a scientific explanation hidden inside the sleeping brain? In this video, you will learn how his early life shaped his unusual mind, how isolation and obsession sharpened his thinking, and how his move from India to England changed mathematics forever. You will discover what modern neuroscience says about sleep and creativity, and how the brain connects patterns during REM sleep without our awareness. You will also learn about lesser-known facts, like how he filled entire notebooks with thousands of results, many without proof, and how these notebooks continued to challenge mathematicians long after he was gone. You will see why some scholars believe his intuition was not magic, but the result of extreme pattern recognition built through years of deep focus, and you will understand how belief, culture, and confidence may have amplified his creative power. This story is not just about math. It is about the hidden abilities of the human mind. It is about how obsession can rewire the brain. It is about how sleep may be one of the most powerful problem-solving tools we ignore every day. By the end of this video, you will understand what was really happening inside his mind, and why his dreams were not random visions, but the final stage of a process that had been building quietly for years. Stay with us until the end, because the final insight may change how you see your own brain and its untapped potential. If stories about genius, mystery, science, and the limits of human ability excite you, then you are in the right place. Welcome to our channel, where we explore the untold stories behind history's greatest minds. Subscribe now and join us as we uncover the truth behind brilliance. In a small town in southern India, far from the great universities of Europe, a quiet boy was growing up in a modest home with very little money and very few resources. And that boy was Srinivasa Ramanujan, born in 1887 into a poor Brahmin family where survival mattered more than scholarship and where books were rare treasures rather than everyday tools. His father worked as a clerk in a cloth shop and earned just enough to keep the household running, while his mother managed the home and carried strong religious devotion that would later shape her son's worldview. And in this simple environment, there were no advanced tutors, no access to famous libraries, no elite academic circles guiding him step by step. Yet from an early age, numbers pulled at him with unusual force, not as symbols on a page, but as living patterns that demanded attention. And by the time he was a teenager, he had already exhausted the basic mathematics taught at school, quickly moving beyond his teachers, solving problems that others could not even understand. And when he came across a book called A Synopsis of Elementary Results in Pure and Applied Mathematics by G. S. Blythe, Satan Peristids, want verkaldemakstavaplias of Tetontikine and Loquenges, want vertontikine and Loquenges Bethquashtik, dark vertontikine and Loquenges coming a meow, dark vertontikine and Loquenges coming a meow, dark vertontikine and Loquenges quashtik, dark vertontikine and Loquenges coming a meow, 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 Dot Patontiki Neonoquanges Cominamiao, Dot Patontiki Neonoquanges Cominamiao, Dot Patontiki Neonoquanges Cominamiao, Dot Patontiki Neonoquanges Cominamiao, Dot Patontiki Car, a dense collection of thousands of formulas with almost no explanations. It became his silent mentor, because instead of being discouraged by the lack of steps, he treated each formula like a challenge, rebuilding proofs on his own, filling gaps with his own reasoning, pushing his mind to explore patterns far deeper than the book intended. And while other students prepared for exams in many subjects, he focused almost entirely on mathematics, neglecting everything else, which led him to fail in other courses and lose scholarships, trapping him in poverty even further. Yet despite this academic failure by normal standards, he continued writing, page after page, notebook after notebook, covering them with formulas that no one around him could verify, results about infinite series, number theory, partitions, continued fractions, and strange identities that seemed to come from a place beyond standard training. And the most shocking part was not that he wrote so much, but that when experts later examined these notebooks, many of the results were correct, not roughly correct, but deeply correct, some even anticipating entire areas of research that would only develop decades later. And this raises a tension that refuses to go away. Because how could a young man with almost no formal advanced education produce mathematics that would challenge trained scholars in places like Cambridge? How could someone outside the system create world-class results without following the traditional path of lectures, mentors, and structured proofs? And this tension becomes even stronger when we move to his own explanation, because Ramanujan did not describe his process in purely technical terms. He spoke about dreams, he spoke about visions. He believed that the goddess Namagiri revealed formulas to him during sleep, and according to accounts from people who knew him, he would sometimes wake up in the middle of the night with ideas fully formed, immediately reaching for paper to write them down before they faded. And what makes this even more mysterious is that he often wrote final results without showing the intermediate steps, leaving other mathematicians confused, because in mathematics the proof is everything. The logical path matters as much as the destination. Yet here was a man presenting answers that seemed to skip the visible journey entirely, and this deepens the puzzle, because how do you solve complex equations without working them out line by line by line? How do you arrive at advanced identities without demonstrating the reasoning that leads there? And when his work finally reached England, after he sent a bold letter packed with formulas to G. Th with Pertov, H. Persik Chatterjee sort of colas, to do H with Pertov, to do H. Persik Chatterjee sort of colas, to do H. Persik Chatterjee sort of colas, to do H. Persik Chatterjee sort of colas, though to long before Runavul Dakwat Pertov, to Dakwat se would you ainu nog fire, it's be a kola be do it powder Pertov, to Dakwat se would you ainu nog fire, 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 to Hardy at Cambridge. The reaction was disbelief, mixed with awe. Hardy later admitted that some of the results looked so strange that he first suspected a trick, but after careful analysis, he realized that many were not only correct but brilliant. And when Ramanujan traveled to England and collaborated with Hardy, their partnership produced important papers. Yet even then, Hardy noticed that Ramanujan's strength was intuition rather than formal proof. He seemed to see the structure of a problem instantly, jumping to conclusions that others would reach only after long calculation. And years later, long after Ramanujan's early death in 1920, at the age of 32, mathematicians continued studying his notebooks, including what became known as the Lost Notebook, discovered decades later. And throughout the 20th century, and even into the late 20th century, researchers proved identities he had written casually, confirming that his insights were not lucky guesses, deeply accurate observations. And modern scholars were stunned by how advanced some of his ideas were, especially in areas connected to modular forms and partition functions, subjects that later found surprising connections to physics and string theory. And this shift in tone is important, because once the shock settles, the explanation must move from mystery toward mechanism, from divine vision toward brain science, since the human brain does not shut down during sleep, but enters different modes of activity. And during REM sleep, the brain becomes highly active, almost as active as when we are awake, reorganizing memories, strengthening neural connections, and linking distant concepts that may not connect during conscious thought. And scientists studying creativity have found that when people struggle with a problem during the day and then sleep on it, they sometimes wake with new insights, because the brain continues processing information in the background, searching for patterns without the distractions of the external world. And in simple terms, if someone spends every waking hour immersed in a single subject, feeding the brain constant input, practicing, calculating, exploring patterns again and again, then sleep becomes a workshop where those patterns are rearranged and refined. And in Ramanujan's case, mathematics was not a hobby, but a total obsession. He had no other career path, no major distractions, no competing ambitions, just numbers filling his thoughts from morning to night. And when a brain is saturated with one domain for years, it becomes extremely sensitive to patterns within that domain. They're able to detect relationships almost instantly, turning repeated exposure into a kind of internal compression. And this is where the concept of intuition becomes powerful, because intuition is not magic, it is compressed experience. It is the result of thousands of repetitions forming shortcuts inside the mind, so that what appears like a sudden leap is actually the endpoint of hidden processing. And while most mathematicians prefer step-by-step logic written clearly on paper, Ramanujan's mind may have performed many of those steps internally and rapidly, presenting him with the final pattern as a whole. And if this internal processing continued during sleep, then dreams would not be random images, but advanced simulations built from stored knowledge, reorganizing formulas, testing combinations, discarding weak links, strengthening strong ones, until a coherent structure surfaced into awareness. And his cultural and spiritual beliefs added another layer, because believing that a divine source was guiding him may have increased his confidence in the results he saw. And confidence matters deeply in creative work, since doubt can block expression, while trust can accelerate it. And if he trusted the origin of his insights completely, he would write them down without hesitation, preserving ideas that others might dismiss. And belief does not cancel intelligence, it can coexist with intense analytical ability, sometimes even amplifying it by reducing fear of error. Yet the story is not purely uplifting, because obsession carries a cost. And Ramanujan's life in England was marked by isolation, cold climate, dietary struggles, and health problems. And his relentless focus on mathematics may have weakened his body, and combined with illness and the stress of being far from home during World War I, his health declined rapidly, leading to his early death. And this darker side reminds us that extreme dedication can strain both mind and body, and genius often exists alongside vulnerability. Yet when all these elements are placed together, the explanation becomes clearer. Not magic, not pure miracle, not luck falling from the sky, but extreme focus shaping neural pathways, deep pattern recognition built through years of solitary practice, a brain trained beyond normal limits in one domain, and sleep acting as hidden computation, refining and reorganizing what had already been intensely studied. So he did not simply dream random answers out of nowhere. He built a mind so specialized and so immersed in mathematics that even when his conscious awareness rested, the internal machinery continued to calculate, combine, and generate structures, allowing him to wake with results that felt revealed, but were in fact the natural outcome of an extraordinary cognitive process driven by obsession, belief, discipline, and the powerful unseen work of the sleeping brain. And as we move deeper into this story, the layers continue unfolding, showing how poverty limited his opportunities, yet sharpened his independence, how lack of formal structure forced him to invent his own methods, how cultural faith blended with analytical rigor, how collaboration with Hardy refined but did not replace his intuition, and how the notebooks he left behind still challenge mathematicians today, each page a reminder that the boundary between conscious effort and subconscious creation is thinner than it appears, and that within the quiet cycles of sleep, the brain may be performing calculations far more complex than we realize, especially when it has been trained with relentless intensity over many years. In the end, the biggest mystery may not be that Srinivasa Ramanujan saw formulas in his dreams. The bigger mystery is the power hidden inside the human brain, a brain shaped by focus, a brain trained with discipline, a brain fed with one idea again and again until it becomes part of its structure. His story shows that the mind does not stop when the eyes close. It keeps working, it keeps building connections, it keeps searching for patterns in silence. What looked like magic may have been the result of years of deep thinking, compressed into moments of sudden clarity. What felt divine may have been the natural outcome of a mind pushed to its limits. And that leads to a powerful question. If one man with limited resources and no formal path could train his brain to operate at such a level, what could your brain do if you focused it deeply enough? What problems could you solve? What ideas could you unlock? What hidden abilities are waiting inside you right now? The story of Ramanujan is not just about mathematics. It is about human potential. It is about the silent work your mind does when you commit to mastery. And maybe the real lesson is simple. Greatness is not always loud. Sometimes it grows quietly, in notebooks, in small rooms, in the dark hours of the night. If this story made you think differently about genius, sleep, or your own potential, make sure to like this video so more people can discover it. Share it with someone who loves science, history, or powerful ideas, and subscribe to our channel for more deep stories about the greatest minds in history. The next breakthrough you hear about might not come from a lab. It might begin in someone's dream,